Welcome back, mathematicians. In this video, we are going to do more work with interval notation. So we have three intervals where we are going to write in inequality notation and graph the intervals. Let's start with graphing. Our first example is the solution set is from 5 to 9, where because the parenthesis is around 5 is a boundary but not included in the solution set, 9 is a boundary but is included in the solution set, and that is because it has a bracket around 9. So let's go ahead and go to our number line, and let's label 5 on our number line and 9 on our number line. And so every value between 5 and 9, because 5 is the left boundary, 9 is the right boundary, will be part of our solution set. So we will shade every value between the value of 5 and 9. And then we need to indicate that 5 is not included in the solution set, but 9 is included in the solution set. To do this, we are going to put a parenthesis at 5 and a bracket at 9. Now to write this in inequality notation, we're going to have to let a variable represent our solution set, so let's choose x. And then we have to have the left boundary, 5, and we know that the solutions are going to be greater than 5. We are not going to put an equal to sign because of the fact that 5 is not included. However, we also know that 9 is the upper bound, and our solution set will include values that are less than 9, but because it has a bracket, that means we need to include the equal to part. So this is the inequality to represent the fact that the solution set is every value from 5 to 9, not including 5, but including 9. Now let's go to 4, infinity. And the inclusion of infinity tells us that this is unbounded in one direction or the other. So let's go ahead and again draw the graph. So I'm just going to go ahead and put 4 in the middle of my number line. Now it says 4 to infinity. This means that since interval notation is always the left bound comma the right bound, that 4 is the smaller or left bound of this number line, meaning that the solution set will include all values greater than 4. Now we need to represent the fact that 4 is not included in our solution set, so we'll use a parenthesis at 4 to show that. So this would be the graph to represent the solution set. Now let's write the inequality. So again, let's start with the variable. We're going to choose x to represent our solution set, and we know that x is going to be compared to 4. Now the question is are the values in the solution set greater than 4 or less than 4? Well, because we shaded to the right, because this is going to positive infinity, it's going to be greater than 4. And because we have a parenthesis at 4, we do not include the equal to sign, so the answer, the inequality, is x is greater than 4. Let's go to the last one, where again we have an unbounded interval. This one is negative infinity to 7. So we're going to put 7 in the middle of our number line. And because 7 is the right boundary, this tells us that the solution set will be all numbers or values less than 7. Now because 7 has a bracket, this tells us that 7 is actually included in the solution set, so we should put a bracket at 7 as well to indicate this. That would be the solution set on the graph. We now need to write the inequality. So again, we have x as the variable to represent our solution set. You could choose a different variable if you'd like. We are comparing it to 7, and so the question is x, the values that satisfy this inequality, are they greater than 7 or less than 7? Well, the fact that it's going to negative infinity, the fact that it is shaded to the left, tells us that it would be less than 7. But because we have the bracket, this tells us that it would also be equal to 7. So the solution set is any value less than or equal to positive 7. All right, guys, good luck.